Okay, so here we are in number 7. So for this one, it's all about which of these 3 functions we're going to plug into. That one, or that one. Which of these 3 should we plug into? They're asking us here f of 4. So they're saying the x value, remember, functions are always f of x, so it's x that's inside. So they're saying x is 4, like that. So if x is 4, look at the 3 zones. This is saying that if x is between -7 and 3, you should plug in that function. This one's saying if x is 3, you should plug in that function. And this one's saying if x is greater than 3, if it's over here, then you should plug in that function. Where's our value? And this one, they're telling us the x is 4. 4 is over here. It's to the right of 3, so we should plug in this function because we have an x value greater than 3. So I'm going to plug into -x plus 6. I'm going to plug in the 4. So -4 plus 6, 2. 2's not there, so it's none of these. Do you see that? It's all about which one you should plug into. If they, for example, let me change the question. If they had said find f of, let's just do f of 1. If they'd said f of 1, where's 1? Is it greater than 3? Is it over here? No. It's between -7 and 3. 1's right here. Well, 1's right here, isn't it? 1 right there. So then I would plug into that function. I'd plug into x plus 3. You plug the 1 in. You'd get 1 plus 3, 4. So you just find the one that you're supposed to plug into. All right, so number 8 here. Which one of these is square root of x? It's this one. Now let me show you this. The practice exam is just examples of the different things that I might put on the exam. So it's not going to be exactly like that, not going to be exactly the same. So you have to be ready. Let me show you the other graphs. There we go. These are the 6 graphs on number 8 that we learned. We learned all these different kind of graphs at different times. So it can be any of those. So make sure you know square root of x and x squared. Put these on your 3x5 card. Square root of x looks like that. X squared looks like that. And then x cubed is a snake going up and down. And cube root of x is a snake going sideways. Snake going sideways. So notice both the third graph, the graphs with 3s, are snakes. The power goes up and down fast because it's powerful, just like this power here goes up fast. And then the root graph, see the 2 root graphs? They both go sideways because they're roots. Rooting numbers don't get big very fast. Like square root of 9 is only 3, right? The numbers don't get big very fast. Absolute value of x is a V shape, and then 1 over x, that one's tricky. Make sure you have all those on your 3x5 card. Number 8 could have been any of those. All right, let's get back to it. So that's number 8. On to number 9. 9, they're asking us for average rate of change. Average rate of change is fancy language for slope. Slope is y2 minus y1 over x2 minus x1. So remember, average rate of change is slope. And slope is y2 minus y1 over x2 minus x1. Okay, so what are my 2 x values? Well, this is x1 and this is x2. So x2 is 6 minus x1 is 5. Okay. Now what do I do on the top? I don't see any y values. Let me spread these out a little bit here. I don't see any y values. Well, that's, remember, y values are function values. This is like f and f. So this is going to be f minus f. Remember, y values are function values. So I'm going to go f, and then this goes straight up here, f of 6. And this goes right here, f of 5, f of 6, and f of 5. What is f of 6? Do you understand what I'm saying when I say? So first off, y values are function values, right? Y's are f's. Y's are f's. So f of 6, f of 5. Now what is f of 6? It means you take this function here and you plug in 6. So it'd be minus 3 times 6 squared minus 6 minus, and then you plug in 5. Minus 3 times 5 squared minus 5. See how I just plugged in for x, 6 the first time, and then 5 the second time? That's what f of 6 means, 6 plugged into f. And f of 5 means 5 plugged into f. So what do we get then? Well, if you work that out, you're going to get minus 3 times 6 squared minus 6 with parentheses minus, and then the other one, minus 3 times 5 squared minus 5 all over 6 minus 5. What does that equal? If you work that out in your calculator, you're going to get, I don't know, I'm going to work it out on my calculator right here. Minus 114. The other one, minus 80, and the bottom is a 1. The double negative is add, as you know, minus 114 plus 80 over 1. You don't need the 1 on the bottom. That's going to be minus 34. Minus 34. There it is. Minus 34. Answer A. So average rate of change is slope. y2 minus y1 over x2 minus x1. We grab the two x values. The y values are function values. So f of 6 and f of 5 we plug into the function that they gave us. Number 10. So they want us to find out where is this thing increasing and decreasing. Well, it's decreasing right there and decreasing right there, and it's increasing in the middle. I think we all know that. But the trick is, how do you say it in this language of interval notation? Basically, it's all about x values. You just grab the x value for this point. That means this is negative pi. To right here, that's this x value. You just grab x values. Intervals only have x values. So it's decreasing from negative pi to negative pi over 2. Decreasing from negative pi to negative pi over 2. That's looking good so far. And then from negative pi over 2 to this one's x value, what's this one? Pi over 2. Again, just the x value. From negative pi over 2 to pi over 2, it's increasing. Negative pi over 2 to pi over 2, it's increasing. And then from pi over 2 to this spot, pi, again, just the x value, pi over 2 to pi, it's decreasing again. Pi over 2 to pi decreasing. It's C. So it's all about the x values of the points tell you the intervals in which it's decreasing, increasing, decreasing. Number 11, average rate of change again. So we know that means slope. y2 minus y1 over x2 minus x1. Average rate of change is slope. So how do we do that? Well, they're saying we should grab the point x equals negative 8. So I'll let this be the x1 and the x2. So the x2 is 4 minus, and the x1 is negative 8. And then above it, I'm going to put the y value right here. I'll put the y value that goes with 4. Where is the dot on the graph that has an x value of 4? It's this one right here. X is 4, y is 0, goes with that. So that's 0 minus. That's the y value that goes with the x value 4. And then where's the x value of negative 8? Right here. And who's the y value that goes with him? 5. So I just put their y value buddies that go with them. That's the difference of y's over difference of x's. What do we get? negative 5 over 4 plus 8, right? The double negative there. Negative 5 over 12. There it is. Negative 5 over 12. That is the slope. What that is, that's the slope between those 2 points. That's what that is. That goes down 5 over 12. Down 5 over 12, rise over run, between those 2 dots, between x equals negative 8 and x equals 4. All right, this one is f of g of 3. How does this work? Well, we take the 3. Now remember, functions, if I write f of x or I write g of x, remember the key point is always inside the parentheses is x. It's always x inside the parentheses. So this must be an x inside the g function. Functions always go right to left. So 3 is in the g function. So go to the g function, which is over here on the right, and start with the x value of 3. So this is the x-axis, 3 is right here. Find the point right above x is 3, right there. 3, 5. X value 3, y value 5. So x is 3, y is 5. So that means when you put 3 into the g function, he spits out a 5. So that means it'll spit out a 5. It's like a toaster. Put in bread, get out toast. Put in 3, get out 5. So now this 5 comes out, and now this 5 goes into f because all of g is inside of f. So that 5 that comes out of g now goes into f. So how do we put 5 into f? We're taking f of 5 now. Well, again, that's the x value. Whatever you put inside a function, that's the x value. So find the 5 on the function, go up, find that point. That's over 5 up 2. The x of 5 gives you back a 2. So the answer is 2. There it is. So that's how it works. Again, you just take that 3, you put it into G, find it, out comes a 5, and then you put that 5 into F, find it, out comes a 2. 13. Okay, so on 13, they want us to do that function. Let's put it back here. So on 13, so we have f of x equals the square root of x plus 3 and g of x equals 3x. And they want us to find f of g of 2. So remember how functions work. They work right to left. That 2's going into g. In fact, I think it's best, let's just rewrite it like this. This is what it really means. It means g, 2 is in g, and the whole thing's in f. All right, so let's start with the inside. What's g of 2? What is that? G of 2. Well, that means you take this function and you put a 2 in. So it's going to be 3 times 2 inside of f, right? I just put the 2 into G. I put the 2 into G. And so I get f of 6. And now 6 is going into f. Now I'm going to put 6 into f. Get the square root of 6 plus 3. Square root of 9, 3. There we go. So when they write this circle thing here, it means double parentheses, f of g of 2. And then put the 2 into g, 2 into g right there. And then that 6 goes into f. Put the 6 into f. Get out 3. Okay, let's try 14 will be similar. They give us f of x is 4x squared plus 2x plus 6, and g of x equals 2x minus 7. And they want g of f of x. Let's rewrite it. what that really means is g with f of x inside, like that. And so that means put all of f of x right here into g. All of this into g. Remember, you plug into the x slot. So it'll be 2 parenthesis minus 7. And plugged in there is the whole 4x squared plus 2x plus x. And then I distribute. I get 8x squared plus 4x plus 12 minus 7. Gather like terms, 8x squared plus 4x, 12 minus 7 is 5. There it is. So again, what happened there, whenever you got that little circle thing, you put one function inside the other. This means all of f plugged into g. So all of f plugged into g, plugged all of f into g right there, and then just gathered like terms, distributed and gathered like terms. All right, 15. 5 minus 2 absolute value, 9 minus 2x equals negative 5. Okay, so it wants me to solve for x. So there's some important steps here that you need to know about. Step 1, so absolute value. How do you solve it? Step 1, get the absolute value below. This is absolute value equations. Absolute value with an equal sign. Get the absolute value alone. So I got to get it alone. So that means subtract the 5 from both sides. So this will be minus 2 absolute value. 9 minus 2x is minus 10. Next step, divide by negative 2 on both sides. It's positive 5. Okay, now, that's all step 1. And now step 2 is you remove the absolute values and you write inside equal to the positive number or inside equal to the negative number. So let's do that. So we take the inside equal to positive 5 or the inside equal to negative 5. See how we do that? That's why do we do that? Because that's logical, isn't it? In other words, if I said, hey, I'm thinking of a number in my head, okay, and the absolute value of it's coming out 5. What does that mean? Just think what do you know about my number? What number could I possibly have in here that whose absolute value comes out to be 5? Couldn't it be 5 or negative 5? Either way, the absolute value would come out to be 5. Well, that's what this is saying. This, don't worry about that it's a big old expression, 9 minus 2x, whatever. Just think of it as number. It's the absolute value, right? These are absolute value signs. Absolute value of some numbers coming out to be 5. What does that mean? That means that whole inside thing, 9 minus 2x, could be 5, or that whole inside thing could be negative 5, right? That's logical. All right, then you just solve each of those equations. Subtract 9 from both sides. We get minus 2x. Is 5, it almost looks like a fraction. It's not a fraction. Let me get rid of these bars. I was just underlining it for emphasis. So I'm subtracting 9 from both sides there. So that comes out, 5 minus 9 is minus 4. Last step, divide by minus 2. X is plus 2. So that's one possible answer. Now the other side, I'm going to subtract 9 from both sides. I got minus 2x is minus 14, and then divide by minus 2 on both sides. It cancels. X is plus 7. So plus 2 and plus 7 are the answers on that question. There we go. And that's actually none of these on the answer. Sometimes the answers are none of these, and that's none of these. Let's go back now to 16. There's 16. Now they want us to do an absolute value question. The whole key, let me point out, it's opposite. Whatever's next to x is opposite for the x value and same for the y value. What is? That's where the center is. That's where the center of the V shape. An absolute value graph, as you can see, all four of them are V-shaped graphs. The center of a V-shaped graph, it's the opposite of what's next to x. So the opposite of plus 5 is minus 5. And then the same as what's out there is y, negative 1. So the center is minus 5 minus 1. Does that make sense? That's the moral of this story. That's what you need to remember, is whatever's next to x. Now they could change it on the exam. It might be something like x minus 3 squared plus 2 or whatever, right? It might not be absolute value. It might be a squared function. Still, you would find the center by doing opposite, same. The x would be opposite, the y would be same. The opposite of negative 3 would be plus 3. The same as plus 2 would be plus 2. The center would be 3, 2. So in our case, the center is opposite of plus 5, negative 5, and the same as minus 1, minus 1. The center is minus 5, minus 1. So which of these four graphs has a center minus 5, minus 1? This one right here. C, minus 5, right? Back 5, down 1. That's our graph. That's the correct center. So that's what they're testing. Do you know what's next to x is opposite? What's outside, what comes at the end is the same for y. Opposite for x, same for y. Number 17, this is the same kind of question, just done backwards. We're looking right here. It looks like this is back 4, the center. Center here is back 4, down, what is that? Down 7. Now remember, this is x and y. Write this better. This is x and y. And x is always opposite and y is always same. So which one has an x plus 4? This one. And a y minus 7. No, this one, D, huh? Plus 4 minus 7. There it is, D. So x is opposite, y is same at the center to the equation. Opposite, same. From the center to the equation, it's opposite, same, x, y. All right, 18. So they want us to do inverse functions on 18. Let's do that. So here on 18, they're saying, remember, f of x is y. This is y is x cubed plus 7. What are the steps for finding an inverse function? Step 1, invert x and y. So these guys trade spots. Becomes x out here, y over there. So step 2, solve for the y. So now we're going to solve that equation for y. Y is saying, I want to be alone. Get rid of all this stuff. So I'm just going to subtract 7 from both sides. Cancels out. And now what am I going to do to turn that into regular y? I'm going to cube root both sides because that cancels it out. So it's cube root of x minus 7. It's this one. That cube root has to go over the whole side. Not like that. That's wrong. That's only over the x, right? I cube rooted the whole right side and the whole left side. There we go. Let's try this next one. Number 19. Same thing. This is y. So y equals 9 over x plus 8. And step 1 again, for finding an inverse function. We're finding inverse functions on all these. Invert x and y. So x and y trade positions. So this becomes x out here and y over there. So that's step 1. Now step 2, what do we do to solve this? Well, now I should say we solve for y. How do you solve when you've got a fraction? Do you remember? Put this over 1 and go diagonal, diagonal, huh? Bring it up here. We have x times y plus 8 is 1 times 9. Distribute. xy plus 8x is 9. 9 times 1 is 9. So y is again saying, I want to be alone. We're solving for y here. So y wants to be alone. So we're going to subtract, or I'm just going to jump it. You can subtract 8x, or I'm just going to grab the whole plus 8x and jump it just to save a step. So that'd be xy is 9 minus 8x. Remember, when things jump to the other side of the equal sign, they switch their sign. So that plus 8x became a minus 8x. Now last step to get y alone, divide by x, divide by x. So there it is, 9 minus 8x all over x. By the way, do you realize that's the same answer as A? See how the order's different on the top? Remember, order doesn't matter. Order does not matter. Only signs in front matter. Order does not matter, only signs in front matter. So what's in front of this 9? Nothing, which means positive. What's in front of this 9? Same thing, positive. What's in front of this 8x? Negative. What's in front of this 8x? Negative. So those are the same exact signs in front. The order doesn't matter, only the signs in front matter. It has the same signs in front. It's the same. A is our answer. Number 20. So this will be the hardest one on finding the inverse. So again, step 1 on an inverse function, invert x and y. So this is y out here. So y will trade with both of those x's. So it'll become x here, and let me see what I'm doing. It's 9x, or it'll become y, won't it? 9y plus 2 over minus 4y minus 7. Like that. Invert x and y. Step 2, solve for y. So how am I going to solve that for y? Put this over 1, diagonal, diagonal. So we get x times minus 4y minus 7 equals 1 times 9y plus 2. And then distribute. So minus 4xy minus 7x, 9y plus 2. Okay, so now things get a little tricky. If you notice, our y terms are in 2 places. We have y in 2 places. So what do we do when we have y in 2 places? Well, this is kind of what we do. Get the y's on the same side. So I'm going to grab this one and jump it over here. It doesn't matter which side. You can get both the y's on the left of the equal sign or get both the y's on the right of the equal sign. It doesn't really matter. Just get the 2 y terms on the same side. So I'm going to go to the right side. It doesn't matter. So 9y. Now remember, when things jump over the equal sign, they change their sign. So that'll become a plus 4xy. Now, and then this 2, I'm going to jump him back here. So this will be minus 7x minus 2, right? That plus 2 jumps over, becomes minus 2. Okay, now, so get the y's on the same side. Step 2. Factor out y with a parenthesis. and then divide. So I'm going to factor out y here. 9 plus 4x. See, I'm getting a little scribbly here. See how I factored out the y? Last step now to solve for this is we divide by 9 plus 4x. Did it. So there we go. There's the inverse function. Now, notice that it doesn't look exactly like any of the answers, but it's the same as this one. Do you see that's the same? Now you might say, well, that looks different signs and everything. Yeah. So the deal with this is, if you ever have a fraction, let's write it down here. We have minus 7x minus 2, right, over 9 plus 4x. If you ever have a fraction and you multiply top and bottom by -1, you're not really changing it, right? Think about just a normal fraction like 2/3. If I multiply top by negative and the bottom by negative, -2 over -3, that's the same as 2 over 3, right? Because two negatives just make a positive. Those are the same thing. That's really positive 2/3, isn't it? So my point is, if you multiply the top and the bottom of any fraction by -1, it might look different, but it's not really any different. You've just made it look different. It's not truly different. So multiply here, you get plus 7x plus 2. Multiply here, you get minus 9 minus 4x. That's exactly what this has. See, both negatives on the bottom, both positives on the top. That means our answer is the same as their answer. So make sure you check that on the actual exam. If you ever have some kind of answer and you multiply top and bottom by -1, you get something else. That's really the same thing. It just looks different. Multiplying the top and the bottom of a fraction by -1 doesn't change it, just like it didn't change it here. 2/3 is the same as -2 over -3. Two negatives is positive. It's the same. They're both the same as positive 2/3. Multiplying top and bottom of any fraction by -1 never changes it, just changes the way it looks. But it's the same value, really. So that's the same as that. They're the same thing. So grab that answer. Grab D here. So make sure you remember that. You can always check by multiplying top and bottom by -1. Good, okay. 21 is asking us to find a slope. I don't know if I have room to do 21 right there. So let me just do it back here. So 21, they want us to find the slope. We've got -2, 5, and -9, -8, and they want the slope. What's the slope? y2 minus y1 over x2 minus x1. This is x1, y1, and this is x2, y2. So y2 minus y1 over x2 minus x1. Okay, so that's -8 minus 5 over -9 plus 2. Write that double negative there, becomes positive. So it's -13 over -7, two negatives, positive 13 over 7. There we go. Now number 22 has all that and more. 22 has 9 minus 44 and 8 minus 39, and they want us to find not just the slope, but the equation. So that's a little more work. All right, so step 1 is to find the slope. You begin by finding the slope, which is, again, y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2. So y2 minus 39 minus y1 minus 44 over x2, 8 minus x1, 9. So we get minus 39 plus 44, right? Double negative is positive, over negative 1. What's that? 5 over negative 1, negative 5. Sorry if I'm getting too sloppy over there. So that should be 5 over negative 1, which is just negative 5. So there's our slope. That's step 1, find the slope. And now, remember how this works? On step 2, you write the slope formula again, this time with the plane y and the plane x, and minus signs and the blanks at the back. And then you grab the slope we just worked hard to find, plug it in there, and grab the x value and put it, just grab the first pair. You can grab the first pair is good enough, or the second pair, it doesn't really matter. Put the x behind the x, put the y behind the y. So minus 44 there, 9 there. So what do we get? The slope is minus 5 is y plus 44, right? Double negative becomes positive over x minus 9. And you know how to deal with that. Put this over 1, diagonal, diagonal. So we get minus 5 times x minus 9. 1 times y plus 44. Distribute. Minus 5x plus 45. Distribute. Y plus 44. Last step to get y alone, subtract 44. Because all the answers have y alone. Y equals minus 5x plus 1. And that answer is actually not there. It's another one of these none of the above answers. There it is. We got it. Okay, so let's try 23. At 2 p.m., Emma left her house, and by 7 p.m., she'd gone 240 miles. What was her average speed in miles per hour? Miles per hour. So miles per hour. How many miles did she go? 240 miles. In how many hours was that? From 2 p.m. to 7 p.m. So that's 5 hours. Divide that on your calculator, you get 48 miles per hour. It's like she was covering 48 miles every hour. On average, her speed was 48 miles per hour. Okay, question 24. So this is a more tricky one. In 1995, the United States recovered 21% of its municipal waste through recycling, up from 17% in 1990. Let P represent the percentage recycled and T the number of years since 1990. Find a linear function, P of T, that fits this data, and then use this function to predict the percentage recycled in 2007. Okay, so how are we gonna do that? Well, what we're gonna need to do here is on these big old word problems, you have to realize that what they're doing is they're giving you 2 points. That's really what's happening here. They're giving you 2 different points. How so? Well, first off, remember the time element. What does it say here? T is the number of years since 1990. Remember these science kind of problems. This is a financial science problem. They always have a starting time when the whole thing starts. And this one is 1990. So therefore, 1995 is 5 years after the start. And 1990 is 0 years after the start. So there's our 2 time elements. Again, they said that let T be the number of years after or since 1990. So they always have a starting time, and you just measure time from there. So 1995, that's 5 years after the start. 1990, that is the starting year, so that's 0 years after the start. Okay, and with that, we're going to put the 21. 5, comma 21. Now, how do I know the 5 goes first and then the 21? Well, see the function right here? p of t. Remember what always goes inside of a function? X, right? So when they put that t inside of the function, p of t, they're telling us the t is the x. And the x always goes first, right? It's always x, y, and the t is the x. So time, the time element, the 5, goes first, and the 21, which is the percentage that they recycled, goes second. That must be the y value. Does that make sense how I knew the 5 went first? Again, because with functions, f of x, you always put x inside. So when they put t inside here, they're telling me that's the x. That's what must go first. So time goes first. So then with these two numbers, which one's going to go first? The time. Which one's the time? The 0, the 1990. 0 goes first, then the 17, because the 0 is the time, and the time is the x. And the x goes first, so time goes first. So there we have 2 points, 521 and 017. Those are our 2 points. Now we use those 2 points exactly like we did a couple of problems back to find the slope and then the equation by cross-multiplying. And then we'll have to do something at the very end. We'll see. Let's go do that first off. So 521 and 017. I'm going to grab these two, 521 and 017. So 521, so this is number 24. So we have 521 and 017. You know the first step is slope. y2 minus y1 over x2 minus x1. This is x1, y1, x2, y2. So y2, 17 minus y1, 21, over x2, 0 minus x1, 5. So that's minus 4 over 5. So there's the slope. And then step 2, we write the slope formula again, this time with the plane y and the plane x and the blanks in the back. And then you grab that slope we worked hard to find and put it where the word slope is. We grab the first pair of numbers, the x, and put it behind the x, and the y, put it behind the y. Okay. So what do we have? Minus 4/5 over y minus 21, x minus 5. And we go diagonal, diagonal, right? Minus 4 times x minus 5 equals 5 times y minus 21. All right, and then we distribute. Boom, 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 boom. Minus 4x plus 20. 5y minus 105. Now we got to get y alone. So add the 105. y equals minus 4x plus 125. Like that. We're good there. And the last step to get y alone, divide through by 5. Boom. So that y equals minus 4/5 x minus 4/5 x. Oh, wait a minute. I've made a mistake way back, didn't I? I'm sorry. Back here. This should have been minus 5, right? Because it's minus 4 over minus 5. 2 minuses is plus 4/5. So this should have been plus 4/5. This is plus. This is plus. This is minus 20. Let me back up to there. I knew something bad was happening. Let's go back there. All right. I messed that up. It's plus 4/5. Like that. Okay, so it should have been like that. And so then this is going to be minus 20. And now to get y alone, I'm going to add 105 to both sides. And I'm going to get 5y is 4x plus 85. And last step, get y alone, divide by 5. Boom. Y equals 4/5 x plus, what's that, 17? Okay, so now we're not done. We're almost done. Bring it up here. It's a long problem. So now we have y equals 4/5 x plus 17. Now let's go back to the question with that equation. Y equals 4/5 x plus 17. Okay, so let me put it right here. So we have y equals 4/5 x plus 17. All right, and we're going to plug in 2007. You see, they're saying use this function to predict the percentage recycled in 2007. Now remember, time started when in this problem? 1990. So 2007 minus 1990, how many years is that? That's 17 years after the start of this little program, this recycling program. So that's what I need to plug in. I need to take that 17, right? 2007, we're supposed to use this function we just found to predict how much was recycled in 2007. 2007 from 1990, since we started in 1990, that's 17 years down the line. So I take the 4/5 and I plug in 17 for the x. Because remember, the x is the t is the time. Right? When they wrote the function p of t, that was like f of x. They were saying the t is the x. The x is the t. They are one and the same. So if the time is 17 years, that goes in for x. X is time. X is t. So hit the buttons on your calculator on that, which I'm doing right now as well. And we get 30.6. So they recycled 30.6%. So that was a long problem. We had to find the 2 points, 521 and 017, and then do all the work with the 2 points to get this equation, y equals 4/5 x plus 17, using slope and everything. And then we had to plug in for the year 2007. That was 17 years after the start. Plug in 17, and we get the percentage recycled. That was a long one. All right, now number 25. If I can get this out of the way here. It says, Daniel is saving money to purchase a home. The amount he has saved is, there it is, so that's the amount he has saved, 5 plus 3t, where t is the number of years after 2020. So here the starting time is 2020, the year 2020. So, in what year will he have saved $26,000? So that means we plug 26 in for A, don't we? They're saying they want the amount saved to be $26,000. So we plug the 26 in for A. And then we'll bring it up here. 26, whoops, I'm getting scribbly, equals 5 plus 3t. We're supposed to solve that equation for t. So subtract 5 from both of those. We're supposed to find what time he will have that, 3t. Let's bring that over here. 21 is 3t. How do we finish solving for t? Divide by 3, boom. T equals 7. 7 years later. 7 years after what? After 2020, that's when it started. So that'd be 2027. There we go. Oh, we could have done the problem right there. All right, so last problem, number 26. They want you to find the slope of the line. Slope of the line. So slope, you know, is rise over run. Rise over run. So start from a point that is real clear. So those 2 points are clearly at intersections of the lines. Now notice these jumps are by 2, right? This goes from 4 to 2, down 2, 4, 6, 8. That was down 8 over 2. So the rise, -8 over 2. That equals -4. The slope is -4. There we go.